We have this eBGP pair policy, which is going to have that next hop unchanged command. So that what that's going to do is when I advertise the route to the PEs in my whatever SP or whatever service provider network, I am not going to change the next hop to me as the route reflector. I'm going to give it to you as, hey, you need to go to the other PE in the other service provider network. This is why you have to redistribute those internal networks, because each PE needs to know how to get to each other, or it will not show up in the BGP table because, as we know, if I can't get to the next hop, best path selection is pretty much useless. That's the first thing that it needs to find out first before best path selection actually happens. Then we have our typical peer session, which is just going to be, remote AS and address update source. I could have put password on here to give it that, TCP 19. You need to know that as well because that may ask you that on a question. It's an MD5 hash and it's TCP 19 is the port for passwords in BGP. I'm gonna give you that free bit of game there because they may ask you about that in some test or something. And then we have the peer session for eBGP, and I want you to pay close attention to one command, which is eBGP multi-hop 255. Now, why would I do this? Well, when you do eBGP, it's saying, hey, I'm directly connected. That's the default behavior. So the TTL value is really like 1, right? Now you could do TTL security and up the TTL security. So you can say, hey, I might be 2, I might be 3 hops away. I'll accept something from like 3 hops away. But eBGP multi-hop is going to say the neighbor that I'm trying to peer to, the TTL value is whatever I say it to. So I put it on 255 to make it the longest TTL value, right? I could have technically did 1, 2, 3, 4, 5. I could have did 6, right? And this would have happened. But I just did 255 to be extremely lazy.